So when we perform multiple operations, we need to know PEMDAS, which is why I had you guys write that down. Okay? So multiple operations on monomials. Most of the time we won't be dealing with addition and subtraction just because at that point it becomes a polynomial, right? When you have more than one term. I think I might do a few examples with you guys where we do have adding and subtracting, but when you get to the worksheet, there's no adding and subtracting. It's either multiply, divide, do what's in the parentheses, or do the exponent. And as long as you follow PEMDAS, you're good. Okay, so P stands for parentheses. E stands for exponent. So let me just write like, I don't know, x cubed or something. So there's the exponent. M stands for multiply. So normally use a dot for that. And then D stands for divide. A for add. And S for subtract. So make sure you do them in that order and you'll be good to go. So let's go ahead and look at the first example. I know when you first look at it, it looks kind of overwhelming, but just remember PEMDAS, okay? So you always want to check, first of all, and you know what? You don't have to write all these steps out because you just wrote PEMDAS out. So these steps are literally PEMDAS. Step one says to do what's inside the parentheses first. Now, a lot of times there's nothing you can do, right? So for example, 6x squared y cubed, there's nothing I can do to simplify that, right? And if it was x cubed and x squared, I could combine those to make x to the fifth. But you do want to check, and you want to check both sets. And there's nothing to do at the bottom either, right? So we can check that step off. Okay, so the P is good. Now we can apply the exponents. Okay, and this goes back to what we just went over. So we're going to take each of these exponents and distribute them. I don't mind if you do that, if you don't write everything out as far as the distribution goes, at least draw the arrows, but you don't necessarily have to do what I'm about to do, which is, break it down into each. I think you'll get it right more often than not if you do it this way, but like I said, you don't have to. So all I'm doing is just distributing it to the top and then going to distribute to the bottom. Now, if you find yourself, you're constantly making mistakes and you're not doing this step I'm showing you, then by all means, you need to go ahead and show your work. So there's the E in PEMDAS. We just applied the exponent. Okay, we're going to continue doing that. So what's 6 cubed? Does anybody remember? Good job. So the 6 cubed becomes 216. And then x squared third becomes x to the 6, right? Multiply. And that y to the 9th. Okay, and in the bottom, we're going to have, yeah, right, 16, x to the 18, y to the 14. Okay, so we can check the exponent step off. Next in PEMDAS is multiply. I don't see anything in here that we can actually multiply, right? I mean, you can't combine x and y terms, and certainly there's no numbers to multiply, so we can go ahead and check. Okay, so next in PEMDAS is divide. Now we can do that, okay? And we have gone over how to divide monomials. So we're kind of combining several lessons into one lesson, right? So they're already lined up. That's good. So all we have to do is just divide each individual thing, right? So first of all, 216 over 16. 13.5. Is it? Okay, so I guess you could write 13.5. Why not? Instead, let's just reduce the fraction. So in other words, what's the biggest number that? Is it? Okay, so 8 would go into both. Okay, so we're going to divide both of these by 8, and you said it was what? 27 over 2. So I'm going to put a 27 on top of the fraction and a 2 on the bottom. And again, we're dividing both by 8. Now, when you divide like bases, does anybody remember the rule for the exponents?
If it's on the bottom, it's negative.
You subtract. Good. Well, actually, your answer is just going to end up being wherever the biggest exponent is. So the bigger exponent here is on the bottom, so I'm going to put my answer in the bottom. 18 minus 6 is? Exactly.
That's same with y also.
Exactly, yes. So with y, the bigger numbers on the bottom, we're going to do 14 minus 9. It's going to be y to the 5th. And that's it, right? There is no adding or subtracting, so we're done. Okay, so it is more involved because we're combining several things here. We're applying an exponent, and we're doing what's in the parentheses, and multiplying if we have to, dividing. So we're kind of putting several lessons together. But that's it. Is similar, but a little different, because the difference here is we have one exponent, right, for the entire thing. All we got to do, though, is actually take that exponent and distribute it to every term in the fraction, because everything's being squared, which means everything is being multiplied by itself. So the 2 is also going to be distributed to the bottom. Okay? And again, I didn't mention this, but you would check in the parentheses to make sure there's nothing you can do. Oh, you know what? I'm glad I did that. We do want to do what's in the parentheses first. In other words, let me just undo all this exponential stuff. That's why it's important to follow steps. Within the parentheses,
Gosh, dang it.
I know. Within the parentheses, we can divide these two, right? Is that not inside the parentheses? That's going to be easier than trying to square it first, okay? And we can also divide these. Again, that's within the parentheses. And we can divide the y cubes. So let's go ahead and do that. What's 6 over negative 3? Okay, so I'm going to write my fraction here. And the step we're doing is what's inside the parentheses. That's what we're working on, so I'll put a P over here. That would be negative 2, correct? That's going to go on the top because the 6 is on the top and it's bigger. X to the 8 over x to the 4th. X to the what? Remember, you subtract the exponents when you divide, so it's going to be x to the 4th. Okay? And then y cubed over y cubed, well, that just cancels, right? It is 1, but anything times 1 is itself, so. You'll see now why we did what's in the parentheses first, because it makes the problem a whole lot easier. Now I don't have to distribute the 2 to the top and bottom. I mean, it would have worked, but it's more work. So PEMDAS saves a lot of time. Now that we've done that, we can apply the exponents. Okay, so there actually is no fraction left. I always do that when I have a fraction just in case, but now it's just a single expression. Very good. So we're going to take the negative 2, distribute the square to that, and we're going to take the x to the 4th, distribute the square to that, and the answer is positive 4, I almost wrote negative, times x to the 8.
Would it make x to the 16? You're squaring the 4. Or just kidding. No. Because you're multiplying it by 2.
Yeah, exactly. So if it was x to the 4th, that would be x to the 16, because 4 times 4 is 16. Remember, multiply the exponents. Somebody brought that up yesterday. That's another easy mistake to make. Okay, so lesson learned. Make sure you do what's in the parentheses first. There's no multiplication to do. We already divided because that was within the parentheses, so that's it for that one. All right, example 3. This is actually missing something, so let me drag this over. That has an exponent of 4 right there. So we have 2 sets of parentheses. And I'll go back to this in a second, but when it says what's inside the parentheses, you always want to go to the innermost layer, okay? In the innermost parentheses, which would be these, okay? that those smaller parentheses are inside of the larger. So we are going to do what's inside of that first. Does anybody notice what you can do with that? It's the only one thing you can do, but you can do something. Multiply what? Close. Starts with a C.
Coefficients.
Coefficients, yes. You can multiply the -3 and the 2. You can't multiply the a to the 4th and the b squared because they're different bases, but you can combine that to make -6.
So that means now you can divide.
Not quite, because there's an exponent here, okay? So we're going to have to do that before we can divide. But anyways, we'll go ahead and do what's inside of the innermost parentheses first, and that is to multiply the -3 and the 2. Okay, so that's going to become -6. And then we're still going to have a to the 4th b squared. And that's still going to be within that exponent. And the bottom's still going to be a squared b to the 7th, okay? But she brought up a good point. We would look to see if we can divide at this point, but what comes before division? Exponent. So we need to now apply this exponent to each of these terms, which is the exponent step. Well, let's go ahead and write this one out. So it's going to be -6 cubed, right? And then it's going to be a to the 4th cubed, and then b squared cubed. Okay, and then we still, let's go ahead and just rewrite the bottom here, not doing anything with it. Remember, we still have a larger exponent of 4. Let's take it one step at a time. So what's -6 cubed? -216, that's right, because it's an odd exponent. And that would be a to the 12th, b to the 6th. And then we have over 6a squared, b to the 7th. And remember, all that is to the 4th power. Okay, so we're still kind of within the P of the PEMDAS because we're working on what's inside the parentheses. We did apply the exponent, but that was because it was inside the parentheses, so we're still falling under that category. At this point now that we've done exponents, we go to M, and there is nothing to multiply for the top and bottom, so we can check that off, but we can divide, okay? Which brings us to dividing each of these out, okay? So -216 over 6, I actually think that works out to an even number. What is that? Is it -36? Okay. That's going to go on the top of the fraction. A squared over a to the 12th over a squared. Yeah, good. And then the bigger one here is on the bottom. So you're actually just going to have a b on the bottom, because 7 minus 6 is 1, and which would be b to the 1st. And I almost forgot. Exactly. This is all to the power of 4. Now we did divide, but we were still kind of working on what's parentheses. So we were still kind of on the first step, which was doing what's inside the parentheses. Now we can apply the bigger exponent. In fact, I might just erase that because we were still doing P. Okay, now we can apply the exponent, which is going to be distributing the 4 to each of those, okay? Because we just divided. So it's going to be the final step here. I need somebody to do 36 to the 4th for me. That's one reason why I'm letting you use a calculator. Is it big, right? All right, give me 1 second here. You said 167?
9616.
9616? Okay. And then a to the 10th to the 4th would be a to the 40. And the bottom's easy. The bottom's just b to the 4th. Okay. Didn't mean for it to come up to that big of a number, but anyway, it did. All right, I am going to do one with subtraction, even though, like I said, you're probably not going to see anything like that on the worksheet. But the reason I'm doing this, what would you do first? I kind of just hinted at it, but you would subtract because it's within the parentheses, okay? So this is kind of a refresher, but what is 3x squared minus 7x squared? So you subtract the coefficients and the variable stays the same for this one. So it'd be negative 5 times negative 4x squared all cubed. So we just did what's in the parentheses. Now we can apply the exponent. So we would not multiply the negative 5 because that comes after doing the exponent in PEMDAS. Yeah, so the 3 is going to go to the negative 4 and it's going to go there. Nope, because it's the exponent only applies to what's in the parentheses. That's why it's up and to the right of the parentheses. If the negative 5 were within there, then yes. Good question. And what's negative 4 cubed? Negative 64. X squared cubed. There we go. Now we've done everything we can for what's inside the parentheses, so now we can multiply. Now, be careful here because when you have a number on the outside like this, and you only have one term on the inside, you're only actually multiplying once. Okay, I've seen people try to distribute. Distribute only works if it was like negative 64 plus x to the 6. Then you would distribute the negative 5 to both, but we only have to actually multiply negative 64. So negative 5 times negative 64, 320. And this is going to be your final answer. Okay, no division to do, no addition, no subtraction. This is a bracket. Like I said, it's the same as parentheses. Yeah, but it's actually not. It really isn't. I'm not just saying that. This won't take long. But we are going to do what's in the parentheses or brackets first. Yeah, okay, yeah, you're right. So we would look for there. That is the innermost layer. Nothing to do there, but what's right outside of it? The 2. Okay? So, yeah, before we subtract that 112x to the 4th, we need to work on the exponent there. So we're going to distribute the 2 to both the 12 and the x squared. So what is, yes, you answered my question before I asked it. 12 squared is 144. And then we're going to have x to the 4th. And then everything else I'm just going to rewrite. Okay, so we're still within those brackets now. So we're going to do what's inside the brackets first before we square it. Okay? So what can we do? Yeah, within the brackets we can actually subtract the top and bottom. So what's 144 x to the 4th minus 112 x to the 4th? 32 x to the 4th. And what will the bottom become? Negative 8x. Okay? And then we still have the squared. Now we're still within the brackets, okay, or the parentheses. I'll put a bracket here. It's the same thing as parentheses. What can you do now within the brackets? you can divide. So 32 over negative 8. Negative 4, good. And what's x to the 4th over x to the 1st? X cubed, okay? And then we still just have the 2 on the outside. Now that we've done what's in the parentheses or the brackets, we can now move on to applying the exponent. So we're going to have negative 4 squared, which is 16, and x cubed squared. Okay. So as complicated as that seemed, it actually wasn't too bad.